Good day class, in today's video we will continue our lecture of our mechanical manipulators forward kinematics in Python. Now we will create the code for our graphical user interface using the TKinter library. But first, we will install again some dependencies in our terminal. Okay. So this one is the ImageTk and the other one is the TKAgg. So ImageTk is for the display of images in our TKinter graphical user interface, while TKAgg will make our graphical user interface simulate our model of our mechanical manipulator. So first we will type sudo apt in our home folder dash get update. Okay. This is to update first our Ubuntu terminal or our Ubuntu OS before we install our other Python package or other Python dependencies. Then enter. Okay, this will be faster because I already installed these dependencies. Okay, next is sudo apt-get install python 3 tk spill python 3 spill image tk. Okay, so this code is to install ImageTk again for the display of our images in our graphical user interface. Okay. So I already installed it. Okay. This is already okay. Next, we will install the TKAgg sudo apt-get install python 3 tk python 3 dev. Okay. So using this, we will install the TKAgg. It will let us simulate our model in our graphical user interface. Okay. So I already installed it, so this will be faster. Okay. Now let's go to our Visual Studio Code and test these installations before we start our coding of graphical user interface using TKinter. Okay, so let's go to Visual Studio Code. Okay, so we also need later our fkin.py codes and model.py codes to complete our graphical user interface. So let's go to TKinter folder, add new file. Let's name it GUI Pi. Enter. Then next is to import our library. Okay. Import our library, which is TKinter. So TKinter is the main library of Python for creating graphical user interface. Okay. So TKinter import space asterisk. Next, we will test first if we already installed the ImageTk and the TKAgg. So from TKinter, we will import photo image. So this is the ImageTk. It's a photo image. Next, let's import matplotlib. Then next, under matplotlib, we will use this code matplotlib dot use close open parenthesis single quotation TKAgg. Okay, let's save it. Let's run it in our terminal. So let's go first to our folder. Our folder's name is Cara V3. Cara V3. Okay, then let's go to our TKinter folder. TKinter. Then from here, we will run our code. Okay, so when we run our code, there is no error. So it means we already installed or the ImageTk and TKAgg is properly installed. Okay. Next, to make this faster, we will import the message box. So from TKinter, we will import the message box for our error messages. Next. Okay, next. Okay, we have an error. Import. Sorry. Then next is import numpys mp. We can copy the imports from our fkin.py, which is import numpys np here. Okay. Next, we will also need the robotics toolbox imports. Okay, this from our model.py. We will need this. Okay, and also this. We will use it here. Robotics toolbox as RTB. Okay, so now our imports are already here. We will create our TKinter code. We will create first our graphical user interface window. So I will name it my GUI equals TK. Okay, so it will work like this. Sorry, it is small letter K. Next, we will add title to our window. Open parenthesis. So we will always use our main variable, my GUI. Then in our close open parenthesis, we will put the title as a string message. We will name it SCARA V3 calculator. Then we'll make our graphical user interface unresizable. It means I will not change the size of my window, my graphical user interface. Then next, I will color it green. Okay, using a beacon figure command. Okay, and using this code BG double quotation inside it is the color green. Then we will make sure this last line GUI main loop will always be at the last part of our TKinter code, because this will compile. This will compile all our code above. It will make this code run. Okay, so let's test it first in our terminal. Okay, the name of this is my GUI.py. Let's run it. Okay, so this is our graphical user interface window. So its background is green. Okay, we can change the color from green to blue. Okay, let's go here. Let's change it to blue. Okay. And let's run it. Okay, this is our graphical user interface window. So this window is unresizable. It means we can change the width and height of this graphical user interface. So we cannot change the width and height of this graphical user interface. Let's close this and go back to our Visual Studio Code. Next, from our window, we will create frames. We will create frames for our graphical user interface. The window and title. Next is the link length and joint variables frame. Mikko and joint variable frame. Okay, so we will create a widget for our frame. So all the functions and variables here in TKinter is a widget. So we will name it fi. Then we will use the code or the command label frame, close open parenthesis. Then we will use again the my GUI variable to create this frame inside the graphical user interface. Then we will create a title for it, a string message title, the name link length, and join variables. Then I will just give it a font size of 5. Okay. Then to position it inside our graphical user interface, we will use the command .grid, close open parenthesis. Then its position will become row equals to 0 and column is equals to 0. Okay. Then we will create the link label, the link length label. Okay, link length label. Okay. So we will name our first link length label variable A1. Then using the label command, close open parenthesis. Inside it is the variable frame fi. Then text as our string message. We will name it A1 space equals space. Okay. Next, we will give it a font size of equals to 10. Okay. Next, we will create an empty box. We will name it its variable A1 underscore A entry close open parenthesis. Then fi. Okay. Our variable again fi. Then we will indicate the width of our entry box and its font size. So the font size will become 10. Then the unit of our link lengths, let's name the widget variable centimeter1 because it is the first centimeter unit. Okay, then we will use again the label command, the fi variable will show our text inside two quotation marks, so centimeter, then font is equals to open parenthesis 10. Okay. So to position it inside our graphical user interface or inside our frame of our graphical user interface, we will use again the grid command. So a1 dot grid, and we will give it a position of row 0 and column equals to 0. Okay. Next, the variable of our uh, entry box, so a1 underscore e, then using again the dot grid, okay, we will put the position of our entry box, so it is beside at the right beside of our a1 label, so we will give it the column 1. Then lastly, we copy this, the centimeter label. We will use the variable cm1 at column 2 because it is beside uh, our entry box. So let's run this and see what it looks like. Okay, so in our terminal, we will run again the Python 3 mygui.py. Okay, this is what our graphical interface looks like. Okay, so the background is not lost. Okay, it's still there. The blue background is still there. What just happened is that we can't resize this graphical user interface. Okay, then I created a frame which is the link lengths and joint variables. Okay. So we will continue creating the labels. I will just copy paste this uh, labels and entry widgets for our A2, A3, and A4. Okay, so just a review, we are creating a TKinter graphical user interface for this mechanical manipulator. Okay, so we have four link lengths and three joint variables. So this is what we will create in this, or what this is what we will design in our graphical user interface. Okay, so A1, let's make it this A2, then A2 will become centimeter 2. This is A3, so become A3, then A3 is centimeter 3, then A4, A4, A4 centimeter 4. Then we'll also copy paste the grids. Okay. So a graphical user interface code is a long code because of copy paste. Lots of copy paste needed in our code. So make sure if you copy paste, you will change the variables. Okay. For the position of A2.grid, it will be located at row 1, not row 0 anymore. For A3, it will be located at row 2. Next, A4 will be located at row 3. Okay. So let's see how it looks like in our graphical user interface. So this is how it looks like. Okay, so you can now enter something in this entry boxes, but it's just an entry. It will not cost anything inside our code or inside our program of our graphical user interface. Okay, next. We will create the joint variable labels. Okay, and we will create it just like how we create the labels, entry boxes, and unit of our link lengths. Okay. So this is a joint variables label or joint variable labels. Sorry. So we will just change this into D1. Our string message should be also changed to D1. Okay, let's name it. Let's name the entry box D1 underscore E. So because D1 is also a unit of length, so this will be centimeter 5. Okay. Next, is the joint variable T2. So T2 is the rotation angle. So it is not a unit of length. Its unit is in degrees or radian, but we will use degrees. So this will be named as the DG1. Then the label text will be DHG. Okay. And let's copy this again. Okay. This is T3, T3E. Become DEG2. Control X, Control S. Okay. Let's see, sorry. How it looks like. Okay. Oh, sorry, I forgot to create the dot grid, command. Okay, so this is for D1. This is for D1E, and this is for diameter 5. Okay, so the position in our frame at row 0, column 3, because they are they are beside at the right side of our label A1. So will be row 0, and the columns will be 3, 4, and 5. Okay, we may add a space at our T1 label, T2 label, and T3 label. Okay, so that it will be so that the units and the label will be separated. Next, for T2, then this is the EG1. Okay, this is row 1. This is row 1. Next is T3. Okay, 3 DEG2. This is row 2. Okay, so let's test it. So let's test this. Okay, so this is how it looks like. So it has the joint variables. Okay, the link lengths and the joint variables. Next, we will add buttons in our graphical user interface. Okay, so to do that, let's copy the format of our frame, the link lengths and joint variable frame here. So this is, we will name this frame buttons. Okay, let's give it a variable. The variable is bf. Let's change the title into forward kinematics. Forward kinematics. Then change this variable and the position. So it will be row 1, column 0. Next, so we'll code the buttons. Widget. Let's give the button widget new variable name. So first is the FK button or the forward button. So we will use the command button plus open parenthesis. Inside this is the variable df. Then the message inside the button, which is forward. Next, the font of the button, of the text inside the button, let's make it 10. The color of the button, let's make it blue. Then next, the font color, let's make it white. Okay, so this will be the widget of our forward button. Let's make the next button. It will be named as the reset button. Okay, so let's name its variable rst. Then its title, the text inside will be uppercase reset. Let's change its color into red. Okay, the font color is white. Then, like the frames and the labels, we will position the buttons inside the frame using the dot grid. Okay, the dot grid command. So the forward button will be at row 0, column 0. The reset button, set that grid will be at row 0, column 1. Okay, Control S. So let's see how it looks like in our terminal. Okay, so we can't see the forward button because it's color blue. Let's change its color into green. Okay, green. Save it. Okay, so this is the forward and the reset button. Okay, so this is the graphical user interface of with the buttons, but the buttons will not activate the calculation yet because we don't have it inside our code. We will create it later. Okay, let's proceed in finishing this design by adding the position vectors frame. Okay. Position vector frame. Okay, so we will just change the variables. So the variable will become PV. Let's change the title of the frame into position vectors. Okay. Then PV after that grid command, and its position will be row 2 column 0. Okay. Next, the labels. Okay. So, because this is just like the linked length label, I will copy the label of A1 here and paste it here. Just change the variable. This will be x. This will become x underscore e. This this will become centimeter 6 because the joint variable is a unit of length. Is in unit of length, so it is also in centimeters. So let's make it for. Let's also copy paste it for y and z. So become y. This is y. This is y. 7. This is z. Become z. This is z. Okay, this is centimeter 8. Okay, so let's see what it looks like in our terminal. Oops, sorry. Oh, sorry. Why? Oh, I forgot. The frames at our label, it should be PV, not FI. It should be PV. So again, be careful in copy pasting. Don't forget to change the variable. This is PV. This is PV. Then I forgot to code first the 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 that grid codes for the position of our position vector labels. Okay. So this is x that grid. So its position will become row 0 column 0 x underscore e is row 0 column 1, and centimeter 6 will be row 0 column 2. Just copy paste this 2 times. Okay. This is y. Y centimeter 7 z c centimeter. Okay, so the position of our y labels is at row 1, and for z is at row 2. Okay, let's check if it's already done. Okay, so this is our graphical user interface where we can compute or calculate the forward kinematics of our mechanical manipulator. So next to this is the calculation of our forward kinematics inside our TKinter code. So will be that will be in our next video. So thank you.